final thing what we are talking about today is distances. Instead of just talking about Uusniemi, I now introduce Dubai. So another big city, and it's over there. So now we have two different locations, and with these two different locations, let's say that you want to calculate the distance between them. So how do you do it? Well,
Euclidean distance?
yes. So what is the formula for Euclidean distance?
Square root of
Square root of? You have these values.
So z minus z1 minus z2 or something like that. The square squared. y1 minus 1.
Okay, so this is Euclidean distance between the 2 points, right? Yes. So that is the Euclidean distance between the 2 points. Now question is that how you want to measure it? Or is this how you want to measure it? Okay, I can say that both of them you may want to measure them. It depends what application you plan to do. If people in Joensuu and Dubai decide to build a giant tunnel through the earth that guarantees very fast travel to between the two cities, they are interested to use the Euclidean. If you are not on surface of the earth, but you are a bit in the space, and you have the 2 points somewhere in space, and you want to calculate how long it takes to send a signal between them. Signal is going to go in a straight line with the speed of light. Depends about the application, but for us and for you and your projects and in general when making location-based applications, we want to know this blue line. How long is this blue line here? So that line is called I think it has many names. It either has the great circle distance. This Haber sign is a function for calculating its distance, and we are going to figure out the function here. So we already know the Euclidean. We know this. We know this red one. It's very easy to calculate, right? You have the formula right here. So if we know this, could we figure out what is the blue length? Yeah, I don't remember. Okay, it has to do with this angle alpha here. And to help us, let's draw this right triangle here. So we have here alpha divided by 2, the angle, and the length here is going to be our Euclidean value divided by 2, so we know it, right? Now, we also know this was our previous radius of the Earth. So we know that. And we want to measure again this blue line here. But let's focus just on half of this blue line from here. So half of it, because it's going to be a continuation of this right triangle from here. So we have from before that sine of alpha divided by 2 is equal to we have E divided by 2 divided by R. Okay. So we have that. We have these things, but now what we want to learn the angle. So how do we figure out this angle here? Is there a function for the inverse of a sine function? We want to get rid of this sign.
Arc sine?
Yes. So now, we have alpha is equal to that. So we have the angle here.
Oh yeah. Oh,
Yeah. Okay. So we have alpha. We know now how big is alpha. So this is our angle. Okay. Can we calculate the circumference of the Earth? It's quite straightforward to calculate the circumference of the Earth. But from the whole circumference of the Earth, we need to take just the part that is corresponding to alpha. So not to 360 degrees, but only for alpha degrees. So now, if we have this situation that 2 pi is going to
Is 360.
yeah, corresponds to 360 degrees, and we know that we want just alpha out of that, then okay, one more thing I'm missing here, I think. Yeah, and for this 2 pi, the circumference is going to be 2 pi r, right? So that's the basic formula. But now for my alpha, what is going to be the circumference? So, sorry? Yes? Can somebody say with confidence? Yes. So I think it is exactly like that. So basically, if you want to have the circumference, you need to have alpha, and we have the alpha already here, and multiply that by r. So just to make sure, yes, it is like that. So I should have checked this beforehand, but yeah. So basically, the Haversine distance is going to be r multiplied by 2 arcsine. If you don't remember what arcsine is, again, look your old math books. But some of you did remember, so that's pretty good. So this is going to be now the Haversine function.